Hello there, Algebras. Welcome to your Chapter 10 Lesson 4 notes on real number solutions. So we're going to look at the types of solutions that we are going to get, and we are going to analyze how we can know what types of answers we're getting when we're solving our quadratic equations. Now, this is kind of a review of a couple of things. One of those things being we have learned 3 methods to solve our quadratic equations. One method was all of Chapter 8. And that was solving quadratic equations by factoring. And when we solved quadratic equations by factoring, we always got rational answers because when we were dealing with solving by factoring, everything we had was indeed factorable. So, of course, that means that all our answers are actually going to be rational numbers. You know, a lot of integers and some fractions that we kept as fractions to keep them as rational numbers. When we started Chapter 10, we started off by solving quadratic equations by completing the square. We made perfect square trinomials. We factored them back into their square binomials that they originally had FOILed from, and then we used that to take the square roots of both sides. If you complete the square on a quadratic of regular general ax squared plus bx plus c equals 0, a standard form quadratic equation, you end up getting the quadratic formula. And much like completing the square, let's spell formula correctly. Much like completing the square, these two processes can solve any quadratic, not just the factorable ones, which means that a lot of our answers here are going to be irrational or not even real numbers. And so if we end up with a negative number under a radical, we are outside of the scope of our real number sets. We know that the rational numbers and the irrational numbers do not actually mix, right? There is no number that is both rational and irrational at the same time. We can't add and subtract their values of rational and irrational together. But also, when we were dealing with our radicals, we never had any values under our radicals that were negative. And that's because those are non-real. We call them imaginary numbers, but they are a real thing, so they are not imaginary. They just, when historically named, were imagined to exist, and they do. But we don't deal with imaginary numbers in Algebra 1. So because of that, because we don't deal with imaginary numbers in Algebra 1, we call those just non-real solutions. And we don't continue simplifying any negative number under the radical. That's usually where we stop and we say, oh, we don't have any real answers, let's move on. But here's how we're going to classify things today. Okay? All of our integers, perfect squares under the radical, repeating decimals, terminating decimals, those are considered rational numbers. All of your fractions, rational numbers. Irrational numbers are, I like to say, your non-numbers. They're non-rational, non-repeating, non-terminating decimals in existence, like pi, like e, those kinds of things, right? These are non-repeating and non-terminating decimals. Any non-perfect squares under the radical, non-rational, not rational, irrational, non-repeating, non-terminating decimals, and non-perfect squares in our radical. Now, the completely not real numbers are any negative numbers under the radical. Anything. Anything that's negative and underneath a radical is not a real number. So we have run into a few of these so far, but here's an example that we got in the notes the other day, a radical negative 64. This would give me no real numbers. Okay. How do I know the number of answers I get when I'm solving a quadratic equation and the type of those answers I get when I'm solving a quadratic equation? Well, I look to my radical. So I've got rational, irrational, or non-real as my potentials, right? Okay, let's kind of get into this and start looking at our values under the radical. Now, I mentioned this word the other day in class when I was talking about solving quadratic equations using the quadratic formula. I mentioned that when you're using the quadratic formula, there's this piece under the radical that I call the discriminant. It's b squared minus 4ac. I use that value to determine the number and types of answers I am getting. So let's think about that. Rather than solve the entire quadratic, when I'm asked how many real solutions are there, all I need to do is think about the discriminant. What is the value that's going to be under the radical? And so since my quadratic equation given is in standard form, ax squared plus bx plus c equals 0, I can pull my a and my b and my c right from the equation and sub those right in and then solve just the discriminant. What is the value I'm going to be getting under the radical? So let's plug that into the graphing calculator. From parentheses, -3, end parentheses, squared, minus 4 times 1 times 7, and we get -19. Okay? Think of this under the radical. Is -19 a real number? No. It's a negative number under the radical. So this is where we would say, rather than solving the whole thing, we know that just this value under the radical is not supposed to be there to get me a real number answer. So I'm going to stop and I'm going to say 0 real roots. This is 0 real answers. 0 real roots. Okay? Let's try another one. What if my quadratic equation is not given to me in standard form? What if it's given to me so that I've got a binomial squared equal to a number on the other side of the equal sign? Well, actually, we were dealing with this when we were solving quadratic equations by completing the square. And I had started to allude to you that if I had this number off to the other side and I already had my binomial squared, I could think in advance about taking the square root of that number already. I could think in advance about that. And I could think in advance about plus and minus radical 6. Is 6 a perfect square? No. Is 6 evenly divisible by a perfect square to simplify it? No also. But since I answered no to the first question, I know that I've got a plus and a minus of this radical. That means there are 2 irrational roots as my answer here, which means if I want to know the number of real solutions, it's 2. Irrational values are real numbers. So this is 2 irrational roots that I get here. This is usually a multiple choice on the Regents exam, which is why we like to specifically talk about how many real number solutions. And then we are going to have this on our test, is a number of real number solutions, a value of real number solutions. Okay, so last one we'll do here is a former Regents exam question, right? How many real solutions exist for x squared plus g squared plus 4g minus 6 equals 0? Okay, so was I given completing the square form or standard form? You're right, I was given standard form of this quadratic equation. So since I was given standard form of my quadratic equation, I am going to, it's ax squared plus bx plus c equals 0, right? I'm going to think about my discriminant, which is the stuff under the radical, which is b squared minus 4ac. So let's plug in a 4 squared minus 4 times 1 in front of the g squared minus 6 in the back as my c value, and let's see what we get. So then let's plug that right into our graphing calculator. So 4 squared in the front minus 4 times 1 times a negative 6. Okay, that negative 6 is going to give me a good balance. That means that I am going to get 40. So what do I think about? I think about radical 40. Now, 40 isn't a perfect square, but it would give me an irrational number, which means that it's a plus and a minus 40, which means there are two real solutions. So two real solutions exist when radical 40 is my number for my discriminant. So notice we have these two ways we can start to think about, okay, how many real number solutions do I have? So I have these two ways and these two methods, either using the discriminant or if I'm already in completing the square form, taking the square root of my actual integer number that I was given and thinking about, is that number a perfect square? Okay. If it's anything positive that's under the radical, you know you're going to have two real answers. Now, what's the way to have only one real answer from a quadratic? We talked about this when we were using the quadratic formula. If you have a 0 under your radical, so I'm going to put that right here. If I have a 0 under my radical, that's when there is only one real solution. If I have a positive number under the radical, that's when I have two real solutions. If I have any negative number under the radical, that's when there's 0 real solutions. For a true quadratic, you don't have 3 answers because you only should have an x squared. 3 answers is for cubics. Okay? So this was a great time to talk about numbers under the radical and how we can simplify them, how we think about them. When we're having negatives under the radical, we don't need to worry and we don't need to do any more. So what I want you to do is I want you to practice this either using the discriminant or getting your quadratic formula with the completing the square form and taking the square roots of both sides. But I want you to be thinking about what makes a number rational, irrational, or not real at all as you're working. And that's how many real solutions you'll have. Okay, make sure you're applying this to the 10-4 notes, or excuse me, the 10-4 homework, and let me know if you have any questions. I will see you very soon, Algebras. Bye.